So this is a little review of projectile motion and how to do it easily on the calculator. So for meters, the formula is height equals negative 4.9 t squared plus v naught t plus h naught, where h is height, t is time, h naught is the initial height, and v naught is the initial velocity or speed. And then for feet, it's just negative 16 instead of negative 4.9. So let's do this example. A signal flare is fired upward from ground level with an initial speed of 285 meters per second. So your equation is h equals negative 4.9 t squared plus 285 t, because negative 4.9 because we're in meters, and 285 because that's the initial speed, and the initial height is 0 because it's launched from ground level. Now, you know it's going to look something like this, except a parabola and not as bad. So time is your x, height is your y. And if you want to know how long it's in the air, well, it's in the air for all of this time, from 0, where it starts, all the way over here, where it hits the ground again. So basically, if we know that's 0, so basically we need to find this point, and then that'll give us the number of seconds that it's in the air. So in the calculator, you go to y equals, and you put it in your equation, negative 4.9 x squared plus 285 x. Okay, so you hit graph. And the default window setting is from like negative 10 to 10, and obviously that is insufficient here. So I don't really... So one way you can do it is hit zoom and go all the way down to zoom fit. I think it's like 10, 0, yeah. Okay, I hate this thing. There we go. Zoom fit. That doesn't really help us too much though, because we don't really care about the negative part. We don't care about negative time, and we don't care about negative height, because it's not going back in time and it's not going below the ground. But I do kind of want to know like maybe how high that is, because I know it's going to keep going higher than that. So if I hit trace, I could go left and right along this curve. So I see here, this is at 4.47-ish seconds, it's 1,175 feet in the air. So if I keep going, so I know I've got to go at least 2,000, so I'm just going to adjust my window. So I hit window, don't care about negative numbers, so I set my minimums to 0. And then for X max, that's like how many seconds do I think it's going to take to hit the ground? I don't know, I'll guess 100. And then how high do I think it's going to go? I was up to 2,000, but it was definitely going to keep going. I'll guess 5,000. Obviously you can just do math, right? But this is kind of assuming that you've forgotten all your math. Okay, so now I see everything, so that's nice. So I'm going to see whereabouts this is. So I'm going to hit trace. And so there I am right now. X equals 50 seconds. It's 2,000 feet up in the air. So I'm going to go along. Well, okay, so it's somewhere between 57.4 seconds when it's 200 feet in the air, and 58.5 seconds where it's like 99 feet below the ground. So we can be more accurate than that. We want to know when y equals 0. So if I go back, and then in y2, enter y equals 0, and graph again. It doesn't show up because it's the x-axis, but I want to find the intersection. So I hit second, trace, for calculate, and I want to calculate the intersection. So it's going to ask if this is the first curve, y1, here it is. You say, yep. Is this the second curve? Well, actually it's a line, but y2 equals 0 is the second thing. Yep. Then it wants to guess an intersection. Here's my cursor right now. You can barely see it blinking. I want to know the one that's over here, not the one that's over here. I know that that's 0. I want to know the one that's over here. So I'm going to put my little blinking cursor close there. So I hit enter, and the intersection is 58.163-ish. So if we go back to our little work, how long is it in the air? Well, from t equals 0 until t equals about 58.163, because those are the two values where the height is 0. So it's in the air for approximately 58.163 seconds. Okay, so then how high does it go? Well, the maximum height always occurs at the vertex, so you can just kind of get an estimate by sort of tracing along. So I don't know, about 4,100, or you can be more accurate by hitting second trace again, going to intersect, no, going to maximum. We're trying to find the maximum, so you find the maximum. Okay, and then it's going to ask you for left bound and right bound. So for left bound, we know the maximum is like there-ish, but I want to make sure I get it. So I'm going to do, there's my left bound, and sure, why not? There's my right bound. Guess, well, guess up here. Hit enter. The maximum occurs at 29.08 seconds and 4,144 feet and a bit. So the vertex or maximum occurs at approximately 29.082 seconds, 44.133 meters. So it goes approximately this many meters in the air. So a balloonist cruising at a height of 2,450 meters sees it. When is the flare level with the balloonist? So we need to know, when does the height equal 2,450? Well, when does y, the height, equal 2,450? So basically we need to find the intersection of the curve and the line. So we need to find this point and this point. Well, I'm going to find the intersection. So intersect. First curve, yep. Second curve, yep. Guess, sure, I'll get the big point first. Okay, so when t equals 47.676 or so, the height is 2,450. And then let's get the other one. So I want the intersection again. Is that my first curve? Yep. Second curve? Yep. But this time I want to go over to the left-hand side. So I'll guess there. Intersection 10.4875, y equals that. Okay, so that tells us that h equals 2,450 when t equals about 10.488 and about 47.677 approximately. So the flare is at a height of 2,450 at about these seconds. So then another question that sometimes asked is, how long is the flare higher than the balloonist? Well, the height is greater than 2,450 when t is between those two numbers. So to figure out the amount of time that it's higher, you just subtract. So it's higher than the balloonist for about 37 seconds.